Imagine shrinking yourself down, past mountains, past cells, past molecules, past atoms. You arrive inside the invisible architecture of reality itself. At the center, a tiny nucleus, and around it, not little balls spinning in circles, not miniature planets, not anything your brain evolved to understand. Instead, you find something impossible, a ghost-like quantum cloud, a region of probability, a wave of potential existence, an electron. Because modern quantum mechanics tells us something terrifying and beautiful. The universe, at its deepest level, is not built from solid objects moving through space. It is built from probabilities. For thousands of years, human intuition was shaped by the visible world. Throw a rock, it follows a path. Watch the moon, it follows an orbit. Observe planets, they move in predictable ellipses. Everything appeared mechanical, precise, deterministic. Then came the atom. The ancient Greeks imagined indivisible particles called atoms, but nobody truly knew their structure. That changed in the late 1800s and early 1900s. Scientists discovered atoms themselves contain smaller particles, electrons, protons, eventually neutrons. Suddenly, humanity faced a question. How are these particles arranged? The first intuitive answer was simple. Electrons must orbit the nucleus like planets orbit the sun. This became the famous planetary model of the atom. Visually elegant, easy to understand, completely wrong. Because classical physics immediately produced a fatal problem. An orbiting electron is accelerating, and according to classical electromagnetism, accelerating electric charges radiate energy. That means an electron orbiting the nucleus should continuously lose energy. It should spiral inward, collapse into the nucleus, and destroy the atom. The math showed this collapse would happen absurdly fast. Atoms should not exist, matter should not exist, you should not exist. Yet atoms clearly survive. Something fundamental was missing. Reality itself was trying to tell us, your intuition is broken. Then came one of the most revolutionary discoveries in human history. Light itself behaved strangely, sometimes like a wave, sometimes like a particle. This duality exploded classical thinking. Then scientists discovered electrons behaved the same way. Electrons created interference patterns, like waves, but also arrived as localized impacts, like particles. How can something be both? Human language begins failing here, because electrons are not truly particles in the everyday sense, nor are they ordinary waves. They are quantum objects. And quantum objects obey rules radically different from classical reality. One of the greatest breakthroughs came from the Louis de Broglie. He proposed, if light can behave like particles, maybe particles can behave like waves. That idea changed physics forever, because if electrons behave like waves, then perhaps atoms survive because electrons are not orbiting objects, but standing waves around the nucleus, just like vibrations on a guitar string. Only certain wave patterns are stable, only certain energies are allowed. This explained why atoms do not collapse. But it was only the beginning. Then came the mathematical revolution. Erwin Schrödinger developed the equation that transformed quantum mechanics into a predictive framework. The famous Schrödinger equation. This equation does not describe tiny balls orbiting. Instead, it describes the evolution of a wave function. The wave function is one of the strangest objects in all science, because it is not a physical wave like water, not a sound wave, not a light wave. It is a probability wave. A mathematical description of possible outcomes. When scientists solved this equation for atoms, they discovered something shocking. Electrons do not move in fixed paths. Instead, they exist in orbitals, probability distributions, quantum clouds. The electron is spread out across space, not localized like a tiny marble. The cloud represents where the electron is likely to be detected if measured. This changed everything. The atom was no longer a miniature solar system. It became a fuzzy quantum structure. Reality itself became statistical. Imagine turning off all human intuition. Now imagine an electron around a nucleus. You cannot point to its exact location, not because your instruments are weak, not because technology is limited, but because the universe itself does not define an exact position before measurement. This is crucial. Quantum uncertainty is not ignorance. It is built into reality itself. The electron cloud is a map of probability density. Bright regions, higher probability. Dim regions, lower probability. The electron exists as a spread-out wave function until interaction occurs. Then suddenly, measurement detects the electron at one location. This is sometimes called wavefunction collapse, though physicists still debate what collapse truly means. The shapes of these clouds are extraordinary. S orbitals, spheres; p orbitals, dumbbell structures; d orbitals, complex flower-like geometries; f orbitals, patterns so strange they look alien. These structures determine chemistry itself. Everything around you, water, DNA, stars, your brain, exists because of quantum orbital structures. Your existence is literally shaped by probability clouds. Then physics became even stranger. Werner Heisenberg discovered a principle that shattered determinism forever: the uncertainty principle. This equation means you cannot simultaneously know both the exact position and exact momentum of a particle. The more precisely one is known, the less precisely the other becomes. This is not a technological problem. It is a property of reality itself. The universe fundamentally refuses perfect certainty. Think about what this means. Classical physics imagined the future as predictable. If you knew every position and velocity, you could calculate everything forever. Quantum mechanics destroys that dream. At the deepest level, nature operates probabilistically. Reality contains intrinsic uncertainty. The universe is not a clockwork machine. It is a probabilistic quantum system. Then came the experiment that terrified even physicists: the Double-Slit Experiment. Perhaps the most important experiment ever performed. Here's what happens. Fire particles through two slits. If electrons were tiny balls, they should pass through one slit or the other. You'd expect two bands on the screen, but instead, you get an interference pattern, like waves overlapping in water. The electron behaves like a wave passing through both slits simultaneously. But it gets stranger. Fire electrons one at a time. Still, the interference pattern emerges. Each electron somehow interferes with itself, as if it explores multiple paths simultaneously. But then comes the horrifying part. Observe which slit the electron goes through, and the interference disappears. Observation changes the outcome. Measurement alters reality. The electron stops behaving like a spread-out wave and behaves like a localized particle.